So the pre-calculus teachers have talked to the calculus teacher who thinks it's very important that we jump to chapter 14, which is finding limits using tables and graphs. So we have only 2 learning targets today, and they're actually very self-explanatory. I can find a limit using a graph. This is learning target number 1. And I can find a limit using a table. We will have 4 examples today, and I will talk to you about the table and the graph portion on most of them. Now, I want to give you what is called the notation for what these things are going to look like, and then tell you how that these are read. So the first thing is that it's abbreviated LIM, which stands for limit. And you're going to read this as the limit as x approaches c. So this c will be a value like 4 or 2 or -3 or 0. And x is going to be your variable that we're using here. And it is going close to this number. What happens to the function as x approaches a particular number, right? And so we're going to say that this is equal to some number n. And I want to show you how this is read. The limit of f of x, or whatever function we're using, like x squared or x minus 5 or x over x plus 4, as x approaches c. So let's look at an example and see what happens here. We are going to find, this is example 1, the limit of 3x squared as x approaches 2. So I want to look at this as a table and a graph, just so that you can see what they look like. All right, so let's first think about the table. I want to choose some x values, and I want to evaluate the function at these x values and see what happens. I'm going to use the number 2, because this is how x approaches 2. And I'm going to see what happens as the values get closer and closer to 2 from the small side, or what they say from the negative side, and what happens to the function as x gets closer and closer to 2 from the positive side. Now let's choose some numbers. From the negative side, I want to choose a number that's very close to 2, like 1.9. I want to choose a number that's close to 2, like 1.99. And I want to choose 1.999. Now, sometimes you're not going to be able to choose the actual number. In this case, I could actually choose 2 and plug it in, and 2 squared is 4 times 3 is 12. So I have a hunch that the answer to this is going to be 12. But let's look and see what happens. I want to choose a number from the positive side, like 2.1, that's very close to 2, or 2.01, or 2.001. You can see how those numbers are getting very much closer and closer to 2. All right, so what we want to do is we want to evaluate our function, which in this case, our function is 3x squared. We'll just write this down here. I'm going to take 1.9, and I'm going to plug it in. So we're going to type 1.9 squared, and we multiply that number by 3, and we get 10.83. And so now next we'll take 1.99 squared, and we'll multiply that number by 3. And I get 11.8803. And now I'll take 1.999 squared, and I multiply that number by 3. And I get 11.988. And I'm rounding these numbers off. Let's take 2.1 times 3 is 12.012, right? And so we're going to look at these numbers as they get closer and closer to 2. Since these numbers are the same, then the limit exists as to what they are approaching. Notice this gets closer and closer to 12 from the bottom. This gets closer and closer to 12 from the positive side. So my final answer is going to be 12, since those numbers are the same. And kind of think about this also. What does 3x squared look like? Well, 3x squared looks like, on a graph, just a parabola, right? If I take 1 and plug it in, that gives me 1, 3, and -1, plug it in, that gives me -1, 3. And so if I take 2 and plug it in, the limit as x approaches 2, well, this number right here is 12. Notice if I come down the parabola from the positive side, and if I come up from the parabola from the negative side, those numbers are approaching the same value. Let's take a look at another example real quick. Example 2. So we want to find the limit as x approaches 3 of 2x plus 6 all over x squared minus 9. Now I want you to notice that if I were to take the 3 and plug it in here, that number would be undefined. So like I did in the first example, where I could sort of think about, if I take the 2 and plug it in, I know that number is going to be equal to 12, and you can see that it does, in fact, from both sides of the table, approach 12. Well, if I take the 3 and plug it into this function, that's not going to work for me. So we have to choose numbers in our table to see what this thing is going to look like. If I'm going to approach 3, let's choose 2.9 or 2.99 or 2.999 with 3 in the middle, and then 3, 3.1, 3.01, and 3.001 as those numbers get closer and closer to 3. So let's evaluate these numbers and see what the values are. So let's first evaluate this at 2.9. 2.99 will be 0.333888. 2.999 is going to be 0.3333888. I'm just going to round those off just a little bit. Now evaluate 3.1 and get 0.3333. And notice, if I look at these numbers, they're getting very close to 0.3 repeating. So I'm going to assume that this is going to be approaching 1/3 from both sides. Let's look at 2 more examples. Find the limit as x approaches -1
smell like dog farts in here.
of x squared plus 2x minus 5 all over 4x plus 4. Okay, and once again, notice if I take the -1 and plug it in, that gives me 0 in the bottom. So I can evaluate the limit just by direct substitution. So I have to choose some numbers that are very close to -1. Now let's think, if I'm coming in from the negative side, I want to do -1.001 because this is less than, these numbers are less than on the left, and then -1.01, and then -1.1. So use the calculator to evaluate these numbers. -1.001 will be 1,499.99975.
Are you not going?
No, I'm carrying this.
So if you look and see what's happening to this number as x gets closer and closer to -1, looks like it's getting larger and larger. In fact, it's getting larger and larger by a factor of 10. So let's call this -14.975. And -0.999 is -1,499.99975. Now look what happens here. From this side of -1, right, this is getting closer and closer to positive infinity. From this side of -1, as it gets closer to -1, it's getting to negative infinity. These numbers are not the same. And remember what we said before, that in order for it to exist, the limit to exist, the numbers have to be approaching the same thing. So we can simply say here, in abbreviation, does not exist. Now let's go ahead and confirm that with a calculator if you were to look at this on a graph, right? Okay, so here's my function that I just typed in here, x squared plus 2x minus 5 over 4x plus 4. Here's the -1 line, right? Here's my y value of -1. And what happens as I come in from the negative side, or numbers that are getting closer and closer, it's shooting up to positive infinity. And what is happening as I'm coming in from the positive side? Right? This is shooting down towards negative infinity as I get closer and closer to -1. These numbers have to be approaching the same thing in order for the limit to exist. And now for my last example, we'll call this example 4. Find the limit as x approaches 0 of sine x over x. And once again, notice if I take 0 and plug it in, that gives me 0 in the denominator, so that's not going to work. We have to choose values that are on the table that are close to 0. Let's choose 0.1, 0.01, 0.001, -0.1. Let's see if we can confirm something with the calculator before we type in the values into the thing. So if we look at sine x over x on the calculator, here's sine x over x. And what happens as it's approaching 0 from the right? Well, it looks like the y value is going to be 1. And what's happening as it approaches 0 from the left? It looks like it's going to approach the same number. Let's confirm that with a table just to be sure. Sine of -0.1 over -0.1 is 0.998. And this is 0.998. So if you notice, this is getting closer and closer to 1. This is getting closer and closer to 1. These numbers are the same, so my limit is 1. I hope this has been helpful. If you have any other questions, please contact me via Remind or email.